Hi, this is Oji Shamit, and I'm here to discuss 9.3D task for SIT 111 through a video to explain the implementation of the hack, hack CPU. Here we have been given the code to explain, to go through it one by one, line by line, and explain the code itself. As you can see, these first seven lines right here are the input and the output of the CPU file itself. It is also called the API of the whole file itself. Now I want to explain the first line is basically a 16-bit memory read for the given RAM address. Then let's go to the second line. It is a 16-bit instruction which can be any instruction like a C instruction or an A instruction. Then there is the reset one. This reset bit, which will be a single bit value, which will basically will reset the whole program counter. And let's start talking about the output bits. So this first one, out M16, it outputs four values and a 16-bit output to store in the RAM itself. Now, in the write M, if the value should be stored in the RAM or not can be decided by the 1-bit write M variable right here. Then we have a 15-bit memory address in RAM where the output can be stored. This line, and then we have a program counter of a 15-bit. So that's the whole API that we have talked about. Now let's talk about the most important section of it, the HDL program itself, the path section. In the path section consists of a lot of gates like not, not, and mux gates, or gates, and whatnot. So let's start with the first one itself, the NOT gates. So let's talk about the first gate, the first NOT gate. If the OOP code in this is 0, then it will be an A instruction. Now, and likewise in the second line, if the OOP code is 1, then it is a C instruction. Now let's talk about the and the mux gates right here. This particular AND gate. We will check whether the ALU or output should go to the A register or not. And if the value of C instruction and the 6 rate is 1, then it will go to the A register as well. And the mux one right here, which will be loaded in mux, which will be loaded in A register. All the incoming instruction or the ALU output will be, this whole scenario will be decided by the selection of bit. If cell is equal to 1, then the ALU output will go to A, otherwise there will be more incoming instructions for it. Now, okay, so let's talk about the OR and the A register bit line of code right here. So in this OR gate, it is used to tell us that the load bit in the A register is 1, if either A instruction or ALU output is fed to A or not. This line right here, it is used to store the value which is fed to the A register itself. Now let's talk about this multiplexer, the mux gate itself. It takes output from A register and the value which is currently stored in the data memory, which is M. Now let's talk about the and the D register right here. The and one, this particular one, it is used to determine whether the ALU output is loaded into the D register or not, and the D register itself is used to implement the load value of D register from ALU. Now let's talk about the ALU. This particular gate consists of control bits such as ZX, NX, ZY, NY, and number of gates, and the output control bits such as ZR and NG, which basically shows the property, which basically shows the properties of the result. So this is the ALU. Let's move on to the last OR 16 gates and complete this one. Alright, so let's talk about the OR 16 and these 3 lines of codes. So now after all this, we have used here 16 bits of gates of OR, and what they basically are used to determine the address and the contents of data memories respectively for the whole data as well. So there's that. And this, the last one, the AND gate is basically used to allow the CPU to write comments in the data memory respectively. Now let's talk about the last load of codes right here. So now in this particular block or chunk of codes which is being used to inform us about the different kinds of jump conditions we can have, I'll just explain you the first two lines of the code so you get the basic idea of what's happening. So now in this particular AND gate, the first one, if the value is 0, then the output will be jump equal to 0, jump equal to. And similarly, if the value is 1, then the output will jump less than. And after that, as you can see, we have different kinds of conditions for all the values that will be contained, and all the different kinds of jump conditions will be loaded through the PC itself. Now let's come to the last line of the code, which is the program counter. It is loaded when the value that will ask the CPU to jump to specific values. If the given conditions are met, and the instruction is whether a C instruction or not, it will totally depend on that. Let me explain it a bit more. PC instruction. So this program counter is basically a register which contains the address of an instruction which needs to be fetched next. So that is the whole code right here. Thank you for watching.